The final part of the energy changes topic is reaction profile diagram. So that's going to be the title for today. And as we have seen, we have got two different types of reaction. We've got an endothermic reaction and an exothermic reaction. So we are going to have two different reaction profile diagrams. And what I mean by reaction profile diagram is just a simple sketch to show you, in terms of energy, what is happening in an endothermic reaction and what is happening in an exothermic reaction. So I'm going to start with the exothermic reaction. And I'm just going to draw a graph, okay? You're never going to be asked to draw this on graph paper. It's only ever a simple sketch. You're never going to be given values for the y or the x-axis. All you're going to have on the x-axis is what we call progress of reaction, although sometimes the x-axis can be left blank, okay? So it's just progress of reaction. And on the y-axis, you are going to have energy. But you're never going to be given numerical values. You're just going to write energy. It's just a rough sketch. So if I had an exothermic reaction, we know that energy is released during an exothermic reaction. So if I were to write on my graph, I'm going to put my reactants here, okay? This tells me that my reactants have this amount of energy. If energy is being released during the reaction, then my products should have less energy than my reactants. If my products have less energy, then when I'm completing my sketch, I just need to put my products lower down on my y-axis than my reactants. So I'm going to put my products down here. Again, there's no numerical values. I just want to compare my reactants to my products. It's exothermic, energy is released, so my products have less energy than my reactants. And if I were to draw a line on my graph to show the change in energy between reactants and products, I would start my line here at the reactants, I would end my line here at the products, and I would write energy change. I'm drawing my arrow pointing downwards to show that energy is being released. If I were to do the same thing for an endothermic reaction, so this is endothermic, again, I'm going to draw a rough sketch. I'm going to put energy on my y-axis, and I'm going to put progress of reaction on my x. In an endothermic reaction, I know that energy is taken in. So if energy is taken in, then my products should have more energy than my reactants. So I'm going to start with my reactants right down here. Because energy is being taken in, my products should be higher on the y-axis, as they will have a greater energy value. The change in energy in this case, again, if you're asked to label the energy change, it's the difference between the reactants and the products. So notice that I'm starting my line exactly at the same point that the reactants are, and I'm ending it exactly at the point where the products are. Don't draw a short little line. Make sure you're extending your line from the reactants the whole way up to the products. And this time I'm pointing the arrow upwards to show energy is going in. And this is my energy change. Okay, so two diagrams, one for exothermic, one for endo. In the exo, the products should be below the reactants because energy is being released and they have less energy than the reactants. The endothermic diagram, the product should be above the reactants as energy is being absorbed and your products are going to have more energy than your reactants. There's one other thing that we need to include on both of these diagrams, and that is the activation energy. So if you remember back to the rates of reaction topic, we came across activation energy, and that was the minimum amount of energy required to start the reaction. So the minimum amount of energy that the particles have to have in order to collide successfully. Basically, the energy you need to put in to kickstart the reaction and get it going. If I were to label the activation energy on my exothermic, okay, I would need to draw something that looks like this. Okay, so I'm basically just drawing a little hill that goes up higher than the reactants and then comes back down. And what this tells me is to get this exothermic reaction going, I need to put in a little bit of energy, that gets the reaction going, and then your reactants can be converted into products. If I'm labeling the activation energy, I'm starting my arrow here at the reactants and I'm going to the top of the hill. Okay, I'm not starting down here at my products, I'm starting with my reactants. Remember, you're going to put the energy in to the reactants to get the reaction going. So you're starting the arrow with the reactants and you're going up to the top of this hill. And this is called the activation energy. Okay, on my endothermic reaction, the rule is still the same. Okay, I'm starting with my reactants and I'm going up higher and then to my products. So I'm going to start down here. Okay, and if I'm labeling my activation energy, I'm starting that arrow with my reactants just as I did over here, and I'm taking that arrow to the top of the hill. And what you will see by comparing the two diagrams is that for an endothermic reaction, you need to put a lot more energy in to get the reaction started. The activation energy is a lot higher in an endothermic reaction than for an exothermic. An exothermic reaction doesn't take much energy to get it started. An endothermic reaction takes a lot more. You are expected to be able to draw these reaction profile diagrams. Often, they'll draw the rough sketch for you and they will ask you to label the energy change and the activation energy. The other way they can ask this is they'll give it to you as a multiple choice question where they'll draw the diagram for you and then ask you to tick the one that's exothermic or tick the one that's endothermic. But you'll never be given values, you're not plotting a graph, you're just doing a rough sketch. Make sure you can draw both of these diagrams, make sure you can properly label them. That takes us to the end of this topic on energy changes. I've attached some exam questions on Show My Homework, which I would like you to complete now. And then if you complete them, go to the next video and I have gone through all of the answers so you can mark them yourself. Obviously, this is a brand new topic that we haven't encountered at all before. So if you've got questions about what I've gone through in the videos, please just message me either on Show My Homework or email me. Okay, more than happy to help you with any questions that you might have. Just let me know.